Okay. So let's look at an alternate strategy for approaching these equations, these fraction equations. The strategy here is called clearing fractions. There's kind of two ways conceptually to do it. It's very similar and related to some of the alternate strategies that we did in 4.7, looking at the complex fractions. Let's start with a couple simple ones, and I'll sort of walk us through it. The idea is find one overall common denominator. You want to look across all of your different fraction pieces, and then you can either rewrite all your fractions over that common value and then essentially wipe it out, or you can do a sort of more technically correct math operation, which would be multiplying by the common denominator. Let me put some numbers up here. Let's do something like 1/6 plus 2/3 x equals, I don't know, 5/8 or something, right? So let's get a little bit of variation here in our denominators. We've obviously got sort of a 6 and a 3. We can just sort of use the 6 there as far as a common denominator. The 8 makes things a little bit more interesting. So let's do, before we do anything else, before we move anything around, let's do common denominator 4, 3, and 6, and 8. 2 at a time, 3 and 6, well, the common denominator, we can just reuse the 6. For 6 and 8, 6 times 8 is 48. They have a 2 in common, right? They sort of overlap with a 2, so that means we can use half of 48 if we divide by 2. Use 24. Also, those are probably small enough numbers that in some sense we could probably sort of figure that out on our own. So the idea here is to rewrite all of our fractions over 24. So let's call this, right, 5/8. We'll do times 3 times 3. 2/3 we'll do times 8 and times 8, and then 6 will be times 4 and 4. So this is really 4 over 24 plus 16x equals, over 24 equals 15 over 24. I'm getting ahead of myself a little bit. So the idea here, right, just like when we did the complex fractions, once all of our values are written over like one common denominator, if everything is written over 24, then the 24 is not really having an impact on the solution, right? Everything is balanced over the same amount. So conceptually what that means is we can essentially just like wipe it out. I can rewrite this equation and it's going to be, effectively equivalent to just doing 4 plus 16x equals 15, right? The idea is if everything is over 24, then the 24 doesn't really have an impact on my final solution, and so then what that means is I can just do the rest of this, do the actual sort of solving of the equation just with whole numbers. We're essentially back to 3.4 stuff, right? So if I just sort of subtract this 4 over, 16x is going to equal 11. Quick division by 16, and I'll get my solution. X is 11 over 16. And so that saves me from having to do the sort of fraction arithmetic in quite as much detail as I was doing before, right? I had to really sort of go through and sort of actually do the addition and subtraction and stuff. This gives me a little bit of an opportunity to kind of just not do that. Let me give you another example. How about, gosh, I don't know. Let's do negative 3/8 x plus 3/10 equals maybe like 6/5 x, something like that. We'll do two different x terms. So again, rather than get really sort of in the trenches with all of the fraction arithmetic, let's just find one common denominator. So this is for 8 and 10 and 5. Didn't necessarily mean to do this, but 10 and 5, we can just sort of reuse the 10. 8 and 10 we'll use 40, right? They have sort of a 2 in common. So 8 times 10 is 80, divide by 2 is 40. So let's multiply all these guys and scale them up. So 3/8, we'll do this times 5 and times 5. Tenths, we'll do times 4 and times 4. And 5s, we'll do times 8 and times 8. So this is negative 15 over 40 with the x, plus 12 over 40 equals 48 over 40x. Okie doke. Everything is over 40, so that means we can just cancel the 40s away from there. They're not really having any impact. So the new version, the sort of simplified version of this equation, is equivalent to negative 15x plus 12 equals 48x. Don't cancel the x's away, right? You're just canceling the denominators off. So to solve it, essentially 2 steps. Let's add the 15x over. Get these x's together on the one side. So that means 12 would be 58. What's this going to be? 63 x. Last but not least, let's just divide this away. So we get here, in some sense, an extremely awkward final answer, 12 over 63. That doesn't look so nice. But you know, we're maybe kind of avoiding some of the math to sort of get us there. Some of the uglier stuff, you know, if given the option of sort of solving one of these equations, keeping the fractions around the whole time, or if I could just sort of wipe them out at the very beginning, and just sort of work with, right, 15s and 12s and 48s. The 15s and the 12s and the 48s sound pretty good. Do one more. I sort of promised you that we would sort of redo the last example from the previous video. So that had a little bit of distribution. It went something like this. And when we did it before, it literally took up the entire page. I'm going to see if I can squeeze it into this just like bottom section of the page here to just sort of demonstrate how this can be a little bit more efficient. I'll try not to cheat too bad by just sort of skipping steps or anything. Regardless, our first step, I would really recommend in I guess in some sense maybe it's not 100% necessary, but I'm going to say, well, nah, you should do this, right? So do this distribution first. Let's not try to fool around with having things in sort of different stages. So definitely distribute first. This for us then becomes, right, when we distribute, you said 2 and 6, that would be sort of 3 and 1. We did this step in the earlier version, right? So this becomes 2/3 minus 5/3 x plus 5/2 equals 13 over 12. Common denominator here between 3 and 3 and 2 and 12. Maybe this is where I can just sort of squeeze in a little bit of work. My LCD across all of those is just going to be 12, right? 3 and 2 would be 6. 6 to 12 would be 12. So do these 3's times 4. 2's times, right, 6 and 6. And then 12 just stays, right? I mean, I can write times 1 over 1, but I guess why? No real reason to. So this becomes, right, so 8/3 minus 20, or no, not 8/3. The point was to do 12s. 8 over 12 minus 20 over 12x plus 30 over 12 equals 13 over 12. And again, the real advantage here was that wipes away all of the 12s. So then this becomes, for us, 8 minus 20x plus 30 equals 13. 8 and 30, that's going to be 38, right? Minus 20x equals 13. So all I'm going to do to sort of finish, we'll add this 38 to both sides. Where are we going to be? Where's that going to take us? 51? So then this is like pushing it a little bit here. Negative 20x equals 51. So divide by the 20. Well, now here's where I'm going to pause, because that's a different answer than what we got before. Right? So that would be x is sort of negative 51 over 20. We had 5/4 before. That's not the best sign in the world, so one of these two went off. Let me in real time see if I can find an error in what I just did, besides not actually having the video visible the whole time. 2 times 1, 2/3. 2 times 5/6. Do that, so 5/3. That checks out with what we did before. Plus 5/2, 13 over 12. So obviously 12 is the LCD. 8 over 12 minus 5/4, 20 over 12, plus 5 and 6 is 30 over 12 equals 13 over 12. I mean, honestly, that all seems fine. Oh, I should have subtracted 38. Ah, rookie mistake. Rookie mistake. See here, right? I have positive 38, and then I'm adding 38 more. I need to do the opposite, right? I need to subtract 38 from both sides. 13 minus 38, that's going to leave me with negative 25. This should be negative 25. So my x is going to be negative 25 over negative 20, which is, of course, 5/4, as we had before. You know, I could redo that whole thing, but I actually kind of like it with the error in there. Hopefully I haven't been making errors like that all along. I think for the most part we've been good. I only caught that one because we had sort of done this problem already and we had something slightly different. And it's a good illustration, actually, if you can see sort of what happens with, you know, that sort of just one tiny change, accidentally adding when I was supposed to subtract, really kind of snowballs and throws all of the rest of my numbers off, even in such a way that, you know, I was ending up at a 51, you know, a positive 51 rather than this sort of negative 25. Made a pretty big difference. I mean, it was different enough that I, who have done this stuff for sort of years and years, didn't at first really see what had happened. Sometimes if you make a mistake and you get a wrong answer, you can kind of reason your correction pretty quickly. That one we had to just kind of go back and check it step by step. So that kind of happened. So I'll leave that in just to sort of show, I guess, that this, you know, behind all this good video content, there is a human person who makes some mistakes sometimes. But just because you make a mistake doesn't mean you can't correct it, as we did. So there you go. That's the end of 4.8. Pretty good section with some pretty good numbers.